Alright, here we are with arithmetic sequences, and so we're going to be talking about arithmetic sequences and the formulas that go with those today. So in an arithmetic sequence, we have a difference, and that difference between the consecutive terms is constant. For instance, if I take a sequence like 2, 4, 6, 8, 10, that's an arithmetic sequence because I'm adding the same thing between the terms. To find that common difference, what we're going to do is we have this little formula. We're going to call that difference D, and we're going to say that that D is equal to A sub n minus A sub n minus 1. Now, you're going to see some new notation here. Don't let this notation fool you. It's actually really easy once you see it in play. So, A sub n is any term in your sequence. Okay, so you just pick a term. So that means that A sub n minus 1 is simply the term before that one. So if I pick the fifth term in the sequence and I subtract the fourth term in the sequence, so A sub 5 minus A sub 4, that would tell me the difference between terms. So in my last sequence I went 2, 4, 6, 8, 10, and so if I took 8 and subtracted 6, that would be the difference of 2. There's two other formulas we're going to look at. One's called the recursive formula, and the recursive formula basically says, look, to find any A sub n, so whether it's the first term, the 8th term, the 12th term, whatever. Let's say it's the 10th term. To find the 10th term, we're going to take, again, the term before it. Okay? So if I know A sub n, then A sub n minus 1 is just a 1 before it. And I'm simply going to add something to it. I'm going to add that common difference. Now you can also do it as f of n. So you could do f of n equals A sub n minus 1 plus d. Okay, so, and actually, this should actually say f of n minus 1 right here. Okay, so we'll change that to say f of n minus 1. Right? So basically, to find a term, that's A sub n. When we say find a term, we're talking about an A sub n. We're going to take the term before it, and we're simply going to add the difference. So again, in my earlier sequence, 2, 4, 6, 8, 10, my next term would be 12, because all I have to do is add 2. An explicit formula comes along, and it'll find any term in the sequence. So in a recursive formula, in order to say find the 10th term, A sub 10, I need to know what the 9th term is. I don't want to have to do that every time. So we have this formula here. It's called an explicit formula. And it says, look, to find any term in the sequence, we're going to take the first term, so we do need to know that. And we're going to add the difference, so we're going to add d, and we're going to add d n minus 1 more times. So think about it like this, okay? If I wanted to find the 10th term in the sequence, all right, A sub 10, that means I would take my first term, and let's just say the difference is 2. So to get from term 1 up to term 10, I would need to add 2 9 more times. So if this is A sub 10, I just want to add that d 9 more times to get there. Okay? And on the right side, you can also write it like this: f of n equals A sub 1 plus d times n minus 1. This one is written correctly, so there's no changes on that one. Basically, in words, it says to find any term. Okay, that's A sub n. That's going to equal the first term plus the difference, n minus 1 times more. Okay, and you'll see that when we go through our examples here. So we've got all of our formulas up here. Okay, remember there was a correction on this formula. It should say f of n minus 1. All right, but here we go. It says find the common difference. Write a recursive and explicit formula. So here we go. The difference on these terms is going to be pretty easy to see. 3 plus 4 is 7, plus 4, plus 4, plus 4. But I can take any term in the sequence, subtract the one before it, and I find my difference of 4. My recursive formula, I'm going to use one of these two guys up here. So my recursive formula, oops, looks like I did difference on the other one first. Okay, so I did an A and B together here. So here we go, recursive formula. A sub n. Okay, so they're always going to start off with A sub n or f of n. So A sub n equals A sub n minus 1 plus D. There's my plus D. I knew that the difference was 4. That's it. That's a recursive formula. Now, if I wanted to use this, okay, so let's say, what do we got up here? We got the number 3 is a sub 1, a sub 2, a sub 3, a sub 4. If I wanted to find a sub 5, which is the next one up here, if you plug in a sub 5 right here, that means it's going to equal a sub 5 minus 1, which is a sub 4. Well, where's a sub 4 in the sequence? It's 15. So that would be 15 plus 4 would be 19. So a sub 5 would equal 19. And you can see that by the sequence up here. Super simple. All right, doing the other side. A sub n equals a sub n minus 1 minus 6. That was my common difference up here. That's all I need in a recursive formula. Okay, explicit takes a little more work. Let's take a look at that. In an explicit formula, take a look up here. So I'm using this first one here, a sub n, to find any term in the sequence. It's the first term plus the difference times n minus 1. Okay, so the question is, what can I fill in? So you're asking yourself, how do you know what to put in? How do you know what not to put in? Do you know a sub n? You don't. So that's a variable right there. That's a variable, which means this n over here is a variable. You can't plug anything in for it yet. I do know what a sub 1 is because that's in my list up here. It's 3. And I do know that the d value is 4. So I'm going to plug those guys in. And I could either leave it just like that, or I could distribute the 4 and simplify a little bit. Okay, so here's our next one. It says, find the indicated term of the given sequence. So we've got 2 examples here. I'm going to try one, and then I want you to try the next one. Okay, so I've got 9, 4, negative 1, negative 6, and then a few blanks in here, and then all of a sudden I'm at a sub 16. So if you're not told what term this is, then you have to assume it's a sub 1. So the number 9 is a sub 1, number 4 is a sub 2, a sub 3, a sub 4, so we're missing a whole bunch of stuff in here. Okay, and I want to find a sub 16. The only way I'm going to be able to do that is using an explicit formula right here. I can't use the recursive because to find a sub 16, I would need to know a sub 15. So I'm going to bring down and I'm going to start to plug in to my explicit formula. Remember, a sub 1 is 9, so I can plug that in. The common difference is pretty easy here. If I take the second term and subtract the first term, I'm actually going to get negative 5. So the sequence is going down by 5s. Okay? So I would start off by plugging in. There's my d value of negative 5, any term minus the one before it. There's my explicit formula, a sub 16. Whatever goes in for this n here has to go in for this n here. Those two always need to match. Okay? And then I just need to finish doing the math on the right side, and I get negative 66. Now you could also sit there and subtract 5, subtract 5, subtract 5, subtract 5, but I don't really want to do that because I'll probably make a mistake. Why don't you try letter B? Take a couple of seconds and try that one. All right, so my difference is 6. This one's pretty easy to see, plus 6, plus 6, plus 6. I'm going to go back to my explicit formula again, a sub 21, which means n over here is 21, and then I just do the math on the right side, 123, done. Okay. The next one down here gets a little bit trickier, and it looks like I have something down here that's not supposed to be there yet, but that's okay. So just disregard this down here. All right, so it says find the missing terms of the arithmetic sequence. Okay, so it looks like these are my missing terms. So there they are, but how did I find those? Okay, so I'm going to go back and I'm going to look at something different, because this one here is different from the one above it. The one above it I knew exactly what D was, I knew what a sub 1 was, so I didn't have to, really do that much work. This one, I know a sub 1, I'm missing a sub 2, 3, 4, and this is a sub 5. So I want you to think about this. If I took a sub 1, let's just say that the difference was 5, okay? And so if I added 5, I would get here. If I added 5 more, I would be here. If I added 5 more, I would be here. If I added 5 more, I should be here, right? So if I take my first term, I would need to add the d value, whatever that d value is, or subtract it, whatever. A total of once, twice, 3, and 4 times. I'm going to do that. I'm going to take my first term, a sub 1, and I'm going to add d once, twice, 3, 4 times. And when I do that, it has to equal negative 22. Hopefully that makes sense. Remember, keep in mind, if I add, or in this case, we know we're going to subtract, right? So let's say subtract 3. If I subtract 3, I would be here. That's once. If I subtract 3, I would be here. That's twice. 3 here, that's 3 times. And 3 here would be here. So all I need to do is be able to figure out how many d's do I need to add. Now, if you're saying, well, wait, you just said subtract, don't worry about it. The negative will fall out when we do the math. Let's clean this up. The d's are 4d. If I subtract 2 on both sides, minus 2 here, minus 2 here, I get 4d was negative 24. Divide out the 4, and I now know d is equal to negative 6. So imagine putting a negative 6 up here. 2, take away 6, take away 6, take away 6, take away 6 would equal negative 22. Now, to find my second term, all I have to do then is take my first term and use my recursive formula. To find the second term, I take the first term and add d. There's my first term. Subtract 6, there's negative 4. Subtract 6, negative 10. Subtract 6, negative 16. All right? So take a look at B. B is the same type of a problem, but it's a little bit different. Look at what's missing here. I'm not given a sub 1 this time. I'm given a sub 6. I'm missing a sub 7, 8, 9, 10. So that means that this 62 out here has to be a sub 11. So let's take a look at how to do this. I know that if I have negative 18, I should be able to add a d. That's once, twice, 3, 4, 5 times. And after adding that d 5 times, it has to equal 62. So I'm basically starting off the exact same way I did in these guys. All right? This is a sub 6. This is a sub 11. Think about that. I went from term 6 to term 11. That's 5, the difference of 5. There's the 5 d's right there. All right? So if we solve this, we're going to add 18 to both sides here. That's going to be 80. And so d is 16. Now, what does it say? Find the missing terms. So now all I have to do is take negative 18, my first term here, add 16, add 16, add 16, add 16. And there they are. Negative 18 plus 16 is negative 2, plus 16, 14, plus 16 is 30, plus 16 is 46. All right, so even though it didn't start at a sub 1, that's not a big deal. All right, it says if the 5th term of an arithmetic sequence is 6 and the 11th term is 36, what is the common difference and the first term? Now, I'm going to take a look at this. This is the way I'm going to write it. I was given the 5th term. I know that that's 6, and I was given the 11th term, which is 36. This problem is exactly like the one we just did. How many d's do I need to add to get from term 5 to term 11? I need to add 6 of them, don't I? Hopefully that makes sense. How many terms are we going up? We're going up 6 terms. 11 take away 5 is 6 terms. All right? Now the way I'm finding d here is a little stick with me on this one, okay? So we could do this exactly the same way we did the last one. We could say 6 plus 6Ds, okay? So my first term plus 6Ds has to equal my last term, right? So we could do it exactly the same way we did example 3, but what's the increase from term a sub 5 to term a sub 11? So I know I'm going up 6 terms, and I'm going up a total of 30 numbers, okay? So in those 6 terms that I went up a total of 30 numbers. All I have to do is subtract the 2. That means that I went up a total of 30 over 6 terms. Think about that. You went up 30 in 6 terms. How much did you go up for each term? An increase of 30 over 6 is 5 each time. Okay? So just a little different way to look at doing this problem, but it's exactly the same as number 3. Now that I know my common difference, okay, I need to find a sub 1. It says, what is the common difference? We got that, that's 5. And the first term. This is where this problem is going to change from the last one. Okay, so again, I could have started it off exactly like the last one to find D, but now I need to find a sub 1. Let's go to our explicit formula. Here we go. A sub n equals a sub 1. This is my variable right here. This is what's missing. Plus d times n minus 1. So, what can I plug in? The most obvious thing is 5 for d, right? Do I have an a sub n? I actually have 2 of them. I have a sub 5 and a sub 11. Those are a sub n's. Watch, let's plug them in. I'm going to use a sub 5. So a sub 5, remember if this is 5 down here, then this has to be 5 inside over here. So a sub 5 is equal to a sub 1 plus the difference, that's the 5 from here, times 5 minus 1. Now, I still have, I kind of did a little baby step here because a sub 5 really is 6, isn't it? The only reason I did this first in this example is because I wanted you to see this 5 here and this 5 here. This subscript n has to match this n over here. But really what I want here is I want the 6 from the a sub 5. So there we go. 6 equals a sub 1. All I did was 5 minus 1 is 4, and 4 times 5 is 20. Now, you just subtract the 20 from both sides, and you get negative 14. Not too bad, huh? All right, let's try another one. Looks like I got some extra information down here. I'm not going to worry about that. Let's see what we got. If the 10th term of an arithmetic sequence is 8, and the 15th term is negative 7, what is the common difference in the first term? Now again, I don't care how you do it, but I would try and turn off the video, give it a look. Alright, so here's my first set of terms. 10th term is 8, 15th term is negative 7. How many terms am I going up? I'm going from 10 up to 15, so I'm going up 5 terms. That's the 5 right there. That's not my common difference, that's just how many terms I have. How much is the decrease from A15 to A sub 10? Alright? So when I went from the 10th term to the 15th term, I went from 8 down to negative 7. Now the easiest way to figure that out is to take negative 7 and subtract 8. Alright? Negative 7 minus 8 equals negative 15. So there's the total drop in numbers. So to figure out what the difference is, all I have to do is put that decrease over my 5 terms. So I have a decrease of 15. That implies negative 15 over 5, which is -3. To find the first term, I'm going to go back to my explicit formula here. A sub n equals a sub 1 plus d times n minus 1. I'm going to pick either one of those two terms up there. It doesn't matter. The nice thing is you can pick either one. All right? I chose a sub 10. And again, I did baby steps here because I wanted you to see this subscript 10 here with the 10 inside the parentheses here. But a sub 10 is really 8. And the math over here, 10 minus 1 is 9. 9 times -3 is -27. So now I just want to add 27 to the right, add 27 to the left, and there's my a sub 1. Okay? Now it looks like we got one more thing here. It says write a formula for the sequence. Okay? So a formula for the sequence is an explicit formula, and it implies that it always starts with a sub n. Take a look. If it says write a formula, they're going to want an explicit formula. A sub n equals a sub 1 plus d times n minus 1. So they're looking for a formula that will find me any term, like the 100th term.